I'm Miss Van Loan, and in this video, we're going to complete Module 1, Lesson 1, Independent Practice. All right, hello ladies and gentlemen. Remember, you can do this lesson in your math notebook, on one of the pages, or on some loose leaf paper. Having lined paper is probably the best. You also want to use a pencil. It can be a number 2 pencil or a mechanical pencil, and have an eraser. So if your eraser is gone, then you may want a separate eraser. I'm going to be using pen just for the video so that it shows up better on camera, but you guys should be using pencil. All right, we're going to label this Module 1, M1, Lesson 1, L1, and then IP for independent practice. And then put your name. All right, let's go ahead and get started. So we do want to write the question, but you don't need to write all of the question. You can shorten it. So number 1 says, what is the additive inverse of 8? And so I'm going to write add inv of 8. And so the additive inverse of 8 is going to be its opposite, whatever you add to 8 in order to make 0. And so in order to show our work, we want to use the method that it showed in the module. So in the module, it showed that we use a number line with 0 in the middle, and the number that we have is 8. So what do we add to 8 in order to get to 0? Well, we would add -8 or take away 8. The other way of looking at this is that it will cancel out with -8 on the number line. So 8 and -8 cancel out to 0. So the answer is -8, and we show our work with this number line right here. Number 2, evaluate. -9 plus 9. So again, we're going to want to use the number line. That's how our lesson for Module 1, Lesson 1 showed us to solve these. And so to show your work, to prove it, you need to do a number line. I know that you probably already know the answer just looking at it, but we need to prove it. We need to show our work. And how do we do that? We show it, we show our understanding, or we draw a proof for this expression by drawing a number line. So we'll go ahead and put 0 in the middle, we'll put 9 on one side, and we'll put -9 on the other, and they cancel out to 0. So the answer is 0. And that's how we prove it. We could draw it this other way where we start it at -9 and then we add 9 to that and then we wind up at 0. Or we could use the additive inverse idea and show the opposites. All right, let's go to number 3. Sorry about my dog barking. What is the additive inverse of -2? Add inverse -2. So just looking at that, we know it's going to be 2 because that's its opposite. But again, we need to prove our understanding using the method that it showed us in Lesson 1. That method is a number line. So -2 and 2, that's its opposite. Okay, number 4, evaluate. -66 plus 66. So we're going to do a number line again. Can you guys tell me what this is just off the top of your head using the additive inverse idea? Yeah, you know it's 0. But we need to prove it. We need to show a mathematical proof using a diagram called a number line. So we're going to start at -66, and then we're going to either show that we're adding 66 to get to 0, Or we could use additive inverse and put negative 66 here, positive 66 here, and show that they cancel out to 0. All right, let's go to number 5. What is the additive inverse of 8,964? Add inv, shortening it, of 8,964. Well, we already can do this in our head quite easily. The additive inverse is going to be negative 8,964. And how do we show that on a number line to prove our mathematical understanding? Well, we put 0 in the middle of the number line. We'll put positive 8,964 on one end and negative 8,964 on the other. Those two will cancel each other out to 0. All right, number 6. Solve for x. Negative 771 plus x equals 0. So in semester 2 of Math 7, you learn how to solve this using an algorithm where we add 771 to one side, add 771 to the other side, draw a line, and then we get that x equals positive 771. But this is semester 1, so we have to solve it using the method that we see in Module 1, Lesson 1. So we're going to use a number line to prove what the answer is. So we're going to put negative 771 on our number line. And then we're going to say, what can we add to that that's going to equal 0? Well, whatever we add to it to give us 0, that's going to have to be its opposite, or additive inverse. So that's how we get x equals positive 771. Using a diagram like we see in Module 1, Lesson 1. All right, number 7. What is the additive inverse of negative 9,276? Okay, let's draw a number line. We'll put negative 9,276. We'll put 0, and we'll put positive 9,276. And again, just looking at it, you should already know that it's going to be positive 9,276 based on that vocabulary word, additive inverse, which means opposite. But we prove it using the number line. I think you're seeing a trend here, right? How do we prove our work? We prove it using the method shown in the lesson. Number 8, evaluate 27 plus negative 27. All right. Again, I know you guys are amazing and you know that this equals 0. But how do we show it? How do we prove it? With a number line. Let's put 0 in the middle, and we're going to start at positive 27. Positive 27. And then we're going to take away 27. There we go. We proved it. When we started at 27, just like in the expression here, we started at 27, and then we took away 27, and we wound up at 0. All right, number 9. What is the additive inverse of negative 12? Add inv of negative 12. What is it, guys? Very good. It's going to be 12. Let's prove it by showing our work. Number line 0 in the middle, negative 12 on one side and positive 12 on the other side. I guess I don't need the positive. I would just got a little carried away there. Number 10, evaluate. I guess I don't need to write evaluate either. I'll just put the expression here. 0 plus 9,276. And I think you can figure that out in your head, right? 9,276. And let's prove it using the method shown in lesson 1. So we're going to start at 0, okay? And then we're going to add 9,276. 9,276. And where do we wind up? Well, we wind up at 9,276. Do you see where this is going? If we start at a number like 1 or 5 or 100, and then we go up 9,276, you'll see how this is going to be translating into some ideas later on? Think about that. All right, we've got some word problems now. Our last two problems, 11 and 12, are word problems. I like to draw a diagram for these, so that's what we're going to do. But before we do that, let's go ahead and write down the gist of the question. We don't have to write down the whole thing, but we're going to write down the gist of it. A diver is 52 feet underwater. Diver, 52 feet underwater. He rises up 25 feet. So goes up 25 feet. How much farther does he need to rise to reach the surface? Okay. How much farther to surface? So that's kind of our 3 sentences there, shortened. So let's draw a diagram. We've got water, and I'm going to put kind of a number line here. We're going to call the surface of the water is 0. And then we're going to say our diver is 52 feet down. Okay, so let's put that about here. Negative 52 feet. That's where our diver is. Give him some flippers. Oh yes, beautiful drawing here. He's probably got a big old mask on, and then some scuba equipment. All right, there we go. Okay, we've got our diver, and he goes up 25 feet. So we're going up 25 feet, and now we're at a new level. So what is this level? So if we've gone 52 from negative 52 up 25, we need to find this new depth. So we're going to take the bigger number, which is 52, and take away 25. 52 take away 25. I'm going to have to borrow because 2 is smaller than 5. So I'm going to make that a 4, borrow, make this 12. 12 minus 5 is 7. 4 minus 2 is 2. So that means we're at 27 below the surface, below 0. Remember, 52 was negative. It's the bigger number, so our answer is going to keep the negative. We're 27 feet below. So how much farther does he have to go? So now we've got to think about this. Farther, how much farther? This is distance. Do we ever do distance in negatives? We don't. So we're just going to say that he's got to go 27 more feet to get to the surface. So our answer is actually going to be positive, even though we're working in negatives because we're below the surface. So whenever you see a word problem, I recommend writing your answer in a sentence. That's kind of a rule in mathematics. If it's a word problem, we write it in a sentence. So our answer is the diver needs to rise another 27 feet. All right there at the bottom of the paper. So the distance is always positive. It's kind of like an absolute value, which you're gonna see here in Module 1 a little bit later. But we're gonna go up 27 more feet. All right, let's look at the next word problem. Number 12. Number 12 says a plane is flying at an altitude of 35,000 feet. Okay, so we've got kind of the opposite situation going on here. Before we were below the surface of the water, now we're gonna be up in the air. Okay, so a plane, 35,000 feet. It descends. That means it goes down 12,000 feet. And then it climbs. That means it goes up 9,000 feet. And then we want to know how much farther does it need to descend, so go down, to land. How much farther to land? So let's draw this. We've got land down here, and then we're going to be up in the sky, and let's say we're right here, 35,000 feet, and we've got our plane. Oh boy. Drawing a plane. Let's see. Hey, that's not too bad. All right, so our plane is flying at 35,000 feet. It goes down 12,000. Okay, flying a little bit. And then it goes back up 9,000. So we go down minus 12, up plus 9. And now we need to figure out what this level is so we can figure out how much farther it needs to go down to land. So we're going to do 35,000 minus 12,000, get that answer, which will be this height right here. And then we'll add 9,000 back to it to get our final height. And that will tell us how far we need to go down. So 35,000 minus 12,000. 5 minus 2 is 3. 3 minus 1 is 2. So this right here is 23,000. Now we're going to add 9,000. And if you, okay, so then we've got 0, 0, 0. 3 and 9 is 12. 2 plus 1 is 3. So now we're at 32,000. That's this one right here. 32,000 is the altitude. So we've got to go down 32,000 feet in order to land. So again, we've got a word problem. We're going to write our answer in a sentence. The plane needs to descend 32,000 feet to land. And let's put a box around it. All right, that's it. We are done with the Module 1, Lesson 1, Independent Practice. Please refer to the other video that shows you how to take a picture of your work and upload it to the assignment page for full credit. Thank you.